Hey guys, welcome to another A Level Maths video. Today we're going to take a look at some more applied maths, and we're looking at mechanics, and we're looking at one of the more earlier topics in the chapter, or the full chapter for mechanics, which is the SUVAT equation, so constant acceleration. These questions can range in difficulty. They can either be quite easy, can be quite challenging. So let's take a look at what we've got here. We've got a nice mix of questions. So the first thing to know is that you are given the 5 equations in the formula book. So the good news is you don't have to worry about memorising them. So, okay, so that makes life a little bit easier. So we just need to know how to use the formulas. So this question here, question 1, taken from one of the old exam papers like usual. So we're told at time t equals 0, a ball is projected vertically upwards from a point O, and it rises to a maximum height of 40 metres above O. So the ball is modelled as a particle moving freely under gravity. So what we've got to do first is show that the speed of projection is 28 metres per second. So part A. So for any question like this, this is how I like to lay out the question. So what I do is I write down my S, my U, my V, A, and my T. Okay? So remember what each one of these stands for. So S is measuring the displacement, U is the initial velocity, V is the final velocity, A is the acceleration, and then T is time. And we write each one of these down from what we can get out of the question. So, for example, we're told that the ball? Yeah, the ball. So it rises to a maximum height of 40 metres. So my S, my displacement, is 40. Now, what I'm just going to also do here is show which direction I'm modelling as positive. So I'm modelling upwards as positive here, okay? Which will be important when we discuss the acceleration in a moment. We want to show that the speed of projection, so in other words, the initial velocity, is 28 metres per second. So that's what we need to find, this U. So what I'm going to do, I'm just going to put a little question mark there. So that's what we need to find. So we note down what we want to find. If it's at a maximum height of 40 metres above O, then what we do know is that the final velocity is 0. If it's at a maximum height, so that's the maximum height. So in that case, V is 0. And we also know A, in this case, is minus 9.8, because we know the ball is modelled as a particle and it moves freely under gravity. So in that case, if we're modelling positive as being up like this, then the effects of gravity would mean it's minus 9.8. And T, we don't have anything for, so we just leave that blank. So we've got 4 values here. Or well, we've got 3 and we've got 1 that we want to find. So in that case, we can use the equations now. So what we do here is we pick the correct equation to use. Now, every now and then you might be able to pick maybe 2 of these equations to use, but more often than not, you'll just have to pick the correct one. So how do I know which one's the correct one in this case? Well, we've got S, U, V, and A. So what I need to do is I need to pick an equation that has all 4 of these variables. So for example, it won't be this first one because we have no T. Again, can't be the second or the third one because again we have no T. So if I look at the 4th equation, V squared is equal to U squared plus 2AS. We've got an S, we've got a U, we've got a V, and we've got an A. Perfect. So we're going to use, using V squared is equal to U squared plus 2AS. Then we can solve here and obtain a value for U, because that's what we want to show, the initial speed for this part. So using this now with the values that we know, so V squared, so that's 0 squared, which is just 0, is equal to U squared, which we don't know, that's what we're looking to find, so that's U squared plus 2 times minus 9.8, which is A, and then times by S, where S is 5. Okay, so what I get here now, if we simplify this, I get U squared minus 784. So all I've done is I've just plugged all of this into my calculator. This is equal to 0. So in that case, if I add 784 to both sides, we get U squared is equal to 784. And then at this stage here, I can take the square root of both sides. Obviously, I can't take the negative solution here because we can't have an initial velocity which is negative. That doesn't make sense. So in that case, U is the square root of 784, which you plug it into your calculator gives you 28 meters per second there. Okay, which is exactly what we want to show. Okay, the speed of projection is 28 meters per second, so as required there. So So that's the first part done. Now if we take a look at part B here, we're asked to find the times in seconds when the ball is 33.6 meters above O. Now, in this question here, the fact that we're looking for time, so plural, that suggests to me that the equation we're going to use, the SUVAT equation we're going to use, will have a quadratic in it. Now, given that we're looking at times, the only two possible answers, or two possible formulas that we could use, would be this one here at the top, sorry, well, the second one down, and this third one, because they both have a quadratic term for t, which is what we're expecting. We're expecting a quadratic term in terms of t. So I've just got to decide which one of these I'm using. Well, let's just write down my SUVAT again. So S, U, V, A, and T. Don't forget we've obtained some new information. So we want to find when the ball is 33.6 meters above O. So our S is different for this one. It's not 40, but it's 33.6 meters. My U, that's my initial speed, my speed of projection. We've just obtained that from part A. That's 28. We don't know what V is. We know A, again, taking it positive to be upwards. That's minus 9.8. And again, T, that's what we're looking to find. So we just put a question mark there. And again, we've got four variables here, S, U, A, and T. So we want S, U, A, and T. So in that case, we're using S equals UT plus a half AT squared. We have no V, so we can't use the third equation. So using S equals UT plus a half AT squared there. Okay. So all I've got to do now is just substitute all the variables in, all the values in for my variables here. So 33.6 is equal to UT, so that's 28T plus a half of AT squared, so minus 9.8 times T squared. So basically I'm doing minus 9.8 here, divided by 2, times by T squared. So in other words, this won't be a plus, it will be minus 4.9 T squared. Okay, and this is perfect. We've obtained now a quadratic in terms of T. So I'm going to make this positive, so it's a bit easier to solve for. So that'll give me 4.9 T squared. So I'm adding 4.9 T squared to both sides. I'm going to subtract 28T off both sides as well. And this is equal to 0 now. So now we're going to solve this. We'd hope we can factorise, but obviously in this case, this is too nasty to factorise. We can't factorise here. So to solve it, I'm going to use the quadratic formula. So applying the quadratic formula, then we get T equals minus B, so 28, plus or minus the square root of 28 squared, minus, so it's going to be 4 times A, 4.9, times C there, 33.6. And then we divide all of that by 2A, so 2 times 4.9 gives us our original 9.8 there. Obviously it's going to be positive because A is positive here. So now all you need to do is start simplifying this and just work out your two values. So it gives me 28 plus or minus the square root of 125.44 divided by 9.8. So because it's plus or minus, we get our two solutions. So in that case, we get T equals 4, and then we also get T equals 12 over 7 there. Okay, so in terms of it being in seconds, that's 4 seconds, 4 seconds, and writing this as a decimal, that'd be 1.7 seconds. Okay, 1.7 seconds there. Okay, so that's that question fully done. Hopefully the last part wasn't too tricky. And it's worth pointing out here, these quadratics, often you will have to use the quadratic formula rather than factorising quite nicely. It's very, very rare that that is the case there. Okay, so that's our first question done. The next question then, again, using our SUVAT equations here. Again, we've got them given from the formula book, so all we need to do is use the correct formula. So let's have a look at the context of this question. So we've got a firework which starts from rest, so that's important. at ground level and it moves vertically. So in the first 3 seconds of motion, it rises 27 meters. We're modelling it as a particle moving with constant acceleration, a meters per second. So we want to find the value of a. So all I'm going to do here is write my s, my u, my v, my a, and my t. So again, I'm taking positive as being upwards. So what can we jot down here? Well, we know the height, the displacement is 27. We know it's starting at rest, so that means our initial velocity is 0 if it starts from rest. We don't know v, there's nothing given for that. We want to work out a, so that's where we put our question mark. And we know the time, we're given that in the question, that's 3 seconds. So t equals 3. So in that case now, we've got our 4 letters again, S, U, A and T, which is very similar, I think, to the part B we've just done. We're going to use S equals UT plus a half AT squared again. So using S equals UT plus a half AT squared. So in that case, S, what is that? That's 27 is equal to UT, so 0 times 3, so that's just 0, plus a half times A, so in this case, we don't know what that is, we'll just call it A, times it by T squared, so 3 squared is 9. So what do I get here? Well, we get 9A over 2 is equal to 27. So 9A over 2 is equal to 27. So I want to solve for A here. So a nice linear equation, times both sides by 2. We get 9A is equal to 54. So we divide both sides by 9 then. We get 54 divided by 9. So we get A is 6. Okay, don't forget your units. So that's the value of A. Part B then, we want to find the speed of the rocket 3 seconds after it's left the ground. So again, I'm just going to clear all this just so we've got enough room. Let's jot down our SUVAT again. So it gets a little bit tedious, but I always would recommend doing fresh SUVAT values just so you can see clearly what you're working with. So the speed of the rocket 3 seconds after it has left the ground. Well, we don't have anything for S, so we're just going to leave that for now. We know it's starting from rest, so it's 0 for our initial velocity. V is what we want to find, our final velocity, 3 seconds after it's left the ground, so we put a question mark there. We know A, that's minus 9.8, and we also know T, that's 3 seconds. Okay, so we've got our 4 values there again, U, V, A, and T. So because we've got U, V, A, and T, the easiest one to just use here is this top one. Okay, V equals U plus AT. So using V equals U plus AT. In that case, well, V we don't know, so it's just V. U is 0, so that's 0 plus AT. Well, A is minus 9.8. Oh, sorry. What I meant about A isn't minus 9.8. Ignore me. A is the 6 that we worked out in part A. Okay. Bit of a mistake there on my part. AT, so 6 times 3. So V is equal to 18 meters per second there. Okay, so sorry about that. Not minus 9.8. Ignore me. Just 6 there. Okay. So that's part B there. So the speed 3 seconds after it's left the ground is 80 meters per second. So that was part B. And then finally for part C, again, if we just clear everything. So what we want to do now is find the height of the rocket above the ground 5 seconds after it's left the ground. So what we're told is that after 3 seconds, the rocket burns out, and then that the motion of the rocket is now modelled as that of a particle moving freely under gravity. So in this case here, we need to split this up into 2 scenarios. We need to consider now from 0 to 3 seconds, and then from 3 to 5 seconds. Okay, so don't forget, from 0 to 3 seconds, we already know the height. Okay, we know in the first 3 seconds the rocket rises 27 meters. So all I need to do now is set up my SUVAT equations for 3 to 5 seconds, work out the height, and then add that to the initial 27 that we've worked out. or we've been given. So SUVAT So let's have a go at working these out. S, the height, the displacement, that's what we want to work out. So straight away, let's put a question mark there. U, well, if we're looking from after 3 seconds, and we know the speed of the rocket is after 3 seconds is 18, then our new initial velocity is also 18. Okay, because that's what it's going to start with. We don't have anything for V. As it's now a particle moving freely under gravity, now our acceleration, if I model it upwards as being positive, our acceleration is minus 9.8, and our t in this case, we're going from 3 to 5 seconds, so t is 2. So we've got S, U, A and T. So in this case, again, we're using the clearly quite popular one here, S equals UT plus a half AT squared. So S we don't know, that's what we're going to work out. UT, so 18 times 2, plus a half of AT squared. So that's going to be minus 9.8 times 2 squared, so times by 4. So at this point here, just plug everything into the calculator. So S is going to be equal here to 16.4. Okay. So from 3 to 5 seconds, we've got a displacement here of 16.4. So in that case, the total height, so the height above the ground, 5 seconds, that will be 16.4 plus the initial 27. So we just write all that down. So the total height, that's going to be 27 plus 16.4. So in that case, we get 43.4 meters there. Okay, that's after 5 seconds. So there we go. So that's that question done. So if we take a look here now at the final question we've got a nice one to kind of finish with here. Again, just using some basic applications of the SUVAT equations. So we're told that a stone is thrown vertically upwards with speed at 16 meters per second from a point h meters above the ground. We know it hits the ground 4 seconds later, so what we want to do first is find the value of h. So like always, with SUVAT equations, write your S, U, your V, A, and your T. Okay. Well, what do we have initially to start with? Well, we want to work out what S is. We're looking for h, so that's S. We know the initial speed is 16 meters per second, so that's U. We don't have anything for V, we don't know the final speed. We know A, that would be minus 9.8 here if I take it to be positive upwards. And we know T is 4 seconds later. So we've got S, U, A and T here. So in this case, again, we're going to use S equals UT plus a half AT squared. Okay. Well, let's plug everything in then. S we don't know. We're going to work that out. U times T, so that's 16 times 4. Plus a half times A, which is minus 9.8, times T squared, so 4 squared, that's 16. If I plug all this into my calculator here, what do I get? Well, I actually get minus 14.4 meters. So what does that actually mean? Well, that's 14.4 meters, so 14.4 meters below the point of projection. Okay. So when I actually write my answer here as h will be positive. It'll be 14.4 there. Okay. So that's part A done. So again, let's write down our SUVAT again. It gets quite tedious, but it's good to be quite rigorous with this. So we want to find the speed of the stone as it hits the ground. So we write everything out again. S, U, V, A and T. So what information do we have? Well, we don't know S. We're not given that in this part. We know U. Our initial speed is 16. What we want to work out is the final velocity here, so that'll be the speed as it hits the ground, so that's what we're going to work out. So we put a question mark there. Again, taking positive to be upwards, A is minus 9.8. And then T, again in this case, it hits the ground 4 seconds later, so T will be 4 for this. So we've got U, V, A and T. So, what can we use here? Well, we can actually use V squared equals U squared plus 2AS. Don't forget we actually worked out S as well, I forgot about that. So yeah, we worked out S, so that's minus 14.4 here. Okay, so we've pretty much got everything here now at this point. So V squared is equal to U squared plus 2AS, I thought I made a mistake. So, plugging everything in then, V squared we don't know yet. U squared, well that's 16 squared there, plus 2 times A times S, so plus 2 times minus 9.8 times minus 14.4 there. So I get V squared is equal to 538.24. So again, I just take the square root of both sides here for V. And remember, we omit the negative solution because a negative answer for V here doesn't make sense. So we get 23.2 meters per second. Okay, and that's the speed of the stone as it hits the ground there. Okay, so I hope this video has helped. That's the very last question there. If there's anything that's unclear at all, just be sure to leave a comment and I'll try my best to help out there. Cheers.